Hello? Hello? Can you hear me?
Yes,
Okay. How are you today?
I'm good at yourself.
Fine, thank you. Let's wait for 5 or 10 more minutes, see if some other people will join, and then we can begin.
Okay.
Okay. Yeah, 7:10. Precisely 7:10. 10 minutes after 7, we can start. Hello, Moni, how are you?
Hello.
We are waiting for for we still have 10 minutes. Sorry, 6 minutes to wait, so that when it's 7:10, 10 minutes after 7, then we can begin. I want at least more people to join. Okay.
Yes, yes.
All right. see. So we have 4 more minutes. I think we have a lot of people have joined, so others can join us later. We can begin. Tonight we decided to have a remote class because of some circumstance beyond my control. Besides, the weather is not even good anyway. So the forecast said wasn't as the weather is not as according to the forecast, it wasn't as friendly as it is last week. So we're even better off having remote tonight. And let me start by sharing with you what we are supposed to be done this week. Before that, I think I need to close some files. Give me 1 minute, just 1 minute. Okay. 1 minute. Let me close some files here. I'm gonna close this one here. Okay. Now, I'm back. So I'm gonna share this with you. Now, this week, this is the week 13, and this is week 13 activities and assignments. So you have 3 assignments due this week. Classwork 11, which I will put after the class is over. Homework 8, due on November 20th. And Excel assignment 5, due on November 20th. Now, for the readings, you can start begin reading chapter 8 of your textbook. Now, let's start the class. Okay. Tonight, our topic of discussion is confidence interval. Let me just make sure that you can see my screen. Okay, there's there's more things I need to remove. Okay, now I think we are good. I think you're good. You are seeing it now. Confidence interval give us an estimate of the range of values that we contain the unknown population parameter. So when we say population parameter, we are referring to those numerical estimates of the population characteristics. Things like the mean, as you can see from here on the screen, the same mean, standard deviation, and proportion. So, for example, we can say that the average or the mean is between 200,000 and 800,000, which means that it can be any value between and including these ranges. So, I mean, it can be 210,000, it can be 290,000, it can be 750,000, so long as it falls within this range. The same way we can say that standard deviation is between 5 to 12. I'm just using arbitrary values. It means it can be between, can be 5, can be 6, can be 7, can be 8. So it gives us a range. Confidence interval give us a range. Instead of using a single number for a mean, for example, we can use a confidence interval give us a lower estimate and an upper estimate of the mean. Now, there's one thing that a constant that we call point estimate. Point estimate give us a single numerical value estimate of the parameter. For example, a bus driver may claim that the average price of gas in 2018. Well, let me use 2022 because this is when we are now. We're now in 2022. It's between $3. Is $3? What I saw today well, I think it's $3.77 a gallon. So, see one number, $3.67 a gallon. Now, first CEO might claim that the company produced on average 200,000 cars in 2013. So you can, again, one number, see, one number. Now, the best point estimates of the population mean is the sample mean. So, now, but for interval estimates, two numbers are involved. For example, the same local bus driver might claim that the average price of gas in 2022, okay, the average price of gas in 2022 is between, you can say it's between $3.50 to $4.50, because that's what we have.
Hello.
Yep. Well, welcome to the class, Miss Tony. So you can see this time we have two numbers, unlike here where you have only one number estimate. Now we have two numbers. See, the lower range and the upper range. That's why I call it interval, confidence interval. The same fourth CEO can also claim that the company produced on average 190,000 cars to 250,000 cars. Again, two numbers. So now we want to be sure that those estimates are correct. So to do that, we use what we call the confidence level. Now, the confidence level is the likelihood that the true population parameter lies within those ranges, okay, that are specified in the confidence interval. Now, usually in statistics, there are three major confidence levels that are popular among statisticians. One is 90% confidence level. In that case, when we say that the average gas price is between $3.50 to $4.50, that means we mean that we are 90% confident. See? So that means our chance of being wrong is 10%. Now, when we say that you are 95% confident, that means we are 90% sure. Sorry, 95% sure that the price is between $3.50 to $4.50, or that Ford produced on average 190,000 to 250,000 cars in 2013. So the confidence level is the likelihood that that population parameter lies within those range is specified in the confidence interval. This one, 99% confidence, those in the pharmaceutical industry must be 99% confident that the medication that they produce do what they are expected to do. So now, other concepts, other terms we use when we're doing confidence interval are the things like the critical value and the critical value basically is a borderline separating the sample statistics. So to get the critical value, we use this formula, Z alpha over 2. Why are we using alpha over 2? Because remember, there are two numbers for confidence interval, the lower side, upper side. So alpha over 2 just show that there are two sides. It's these two sides, two tails. Now, there are other ways you can get the critical value, but a shortcut method is to use this formula, P over 200. Z alpha over 2 equals P over 2 and 200. Why? Again, remember I told that there are two sides, lower side and upper side. So instead of the percentage is over 100, but since there are two sides, we're talking about 200. So that's a quick portable formula for finding it, confidence critical value. Let's do an example of that here. Let's say, look at this. Now, I remember I mentioned that you should print this table and keep it handy. I mentioned it 2 weeks ago that we'll be using these tables from then onwards. So now we'll be using this table again. we'll be using table 5. Okay. Now, we need it to calculate the critical value. So let's do this example. Says, for 90% confidence interval. Remember the formula is this, P over 200. So I'll paste it here so you can see it. Let me make sure. Yes. So we'll be looking at the formula while we calculate it. For 90% confidence, the alpha, your chance of being wrong is 10%. If you're 95% confident, your chance of being wrong is 5%, which is your alpha. If you are 99% confident, your chance of being wrong is 1%. Okay. Now, the first question says, okay, let me show you these two of these, then we can go to that question. Now, if you want to find the critical value for 90%, all you have to do is to use this formula. So you have critical value Z, critical value, okay, which is Z alpha over 2. Okay. I want to make it up to 16 so that we can see it clearly, which is Z alpha over 2. For alpha, I'm going to use this alpha here so that it will save us time. Alpha over 2 equals say P over 200, and our P here is 90. So we have 90 over 200. Okay. I'm gonna make this so that it will be in 1 minute. Okay, 90 over 200, which is now we go to our calculator. 90 divided by 200. 90 divided by 200 give us 0.45. And when you look at those tables here, you will see that all of them have 4 numbers, 1, 2, 3, 4. 5. So even though we get 0.45, we're gonna write 0.4500 so that we make it 4 numbers. Now, once we got that, we can now look at the table to find the Z value that corresponds to 0.4500. I'm going to make it so that it won't be too bold. Okay. So now let's go and look for Z value that corresponds to 0.4500 in the table. We go to the table, 0.4500. So you see 0.4495. We saw 2 of them. 0.4505. So let's see which of them are, we don't see 0.4500 exactly. We saw only 2 numbers that are close to it. Let us see which of them is closest to it. Remember, we are looking for point. So ignore the for this our 0.4500 here. Just ignore the decimal point and write it as 4500. And then the 2 numbers we saw that are closer to it are excuse me. I have 4495 here. 4495. I'm writing them down, and then this one here, 4505. Let us check which of them is closest to them. So we go to our calculator to find out which is closest to that one. So I'm going to put 4500 minus 4495. So it is 5 points away. Now, well, let's try the other number. Clear, I have 4505 minus 4500. It's also 5 points away. So both of them are equally close to 4500. So when they are equally close, what you're gonna do is to use the closest number, which is this one. I mean, the largest number, which is this one. Follow it to the left. We got 1.6. Follow it up, 5. 1.6, so that the answer becomes 1.65, making the critical value to be 1.65. Any question about this? Any question? Good, good, very good. Now, so the critical value is 1.65. Okay. Now let me do another one here. Like if it is 95% confidence interval, the alpha is 0.05, which is 5%, which means that your chance of being wrong is 5%. So let's find the critical value for that. Again, we put the same number. I'm going to copy this and just put the numbers in. So the critical value, in this time, we are doing 95 over 200. Remember, the formula is pi and p over 200. So 95 over 200. Let's get its answer from our table of from our calculator. 95 divided by 200 give us 0.475. Now, given that the numbers in that table are four numbers, 4 figures, so we're gonna make it 0.4750. Okay, make it 4 numbers. 0.4750. Now we can look for this on the table. We go to the table. Okay. Of 0.45 we're looking for 0.4750. So 4750 on the table. Look for it. 470. We are lucky this time. We find exactly 4750. Follow it to the left. 1.9 and up 6. 1.96. So we got 1.96 on that. So the critical value is 1.96. So that will give us 1.96 here. So that's how you find the critical value. 0.99, you might try this too as a practice at home. And I want to show you something. On the table, you can also see that they have it already calculated on the table. If you look at, this is table 5. If we go to table 7, I think it's table 7. Yeah, this is table. Oh, it doesn't have a title. But see, level of confidence. You can see that they have for 0.75 is 1.515 is critical value. They use ZC. We use alpha over 2. It's the same thing. For 0.8, we have 1.28. For 0.85, 1.44. For 90, 1.645, which is the same as 1.65 that we got in our calculation. See, for 1.65 for 90. And they got 1.645, see, which is approximately 1.65. For 95, they got 1.96, which is the same thing that we got for our own 1.96. See? Now, okay. Let's look at the question. Right? And this question, finding critical values. You say find the critical value for Z alpha over 2 corresponding to 95% confidence. We did that already. We find it here. See? So I'm gonna copy this version and just paste it here because we did it already. I'll paste it here. Okay. I'll make this one make it 16. Okay. Now, next one it says here, find 99% confidence level. That is, you mean find the critical value. We did that already for 99. Oh, we haven't done that for 99. We haven't done it. So let's do it. For 99% confidence level, solution is the same process. Same process. Okay. Now, if the critical value is given to you, you don't have to find it. But if it's not given to you in a question, then you have to find it first before you answer the question. So this is our critical value. So, but this time around, we're looking for 99% confidence level. So we're going to be using 99 instead of 95. So we change this to 95, 99. So the critical value, Z alpha over 2 is 99 over 200. Now we go to our calculator and find 99 divided by 200. 0.495, because the table will have 4 figures. So you're going to make it 0.4950. 0.4950. 0.4950. Okay. Now, we now look into the table to see the number that is closest to this. 0.4950. We go to our table, 0.4950. It's on table 5. Okay, which is the area under the standard number distribution. 0.4950. 495, 4950. I saw 4949 and 4951. So what you're gonna do is you choose the one that is closest. But this is 4949, which is 1 point away. This one is 4951, which is also 1 point away, because what we have is 4950. So both of them are equally close. Again, we use the one that is larger, which is 49. What is it again? 4951. So we follow it to the left, which is 2.5 for Z. 2.5 and up 8. 2.58. So we write 2.58 for the tables. 2.58. And we can go up and put that there for 99, 2.58. So you can try as much as example as you can at home. Any question before we move on to the next one?
No.
Good. Now, we can now look at the confidence, how to calculate the confidence interval. The confidence interval for the mean, when the standard deviation is known and the sample size is large. In statistics, we say that the sample size is large when it is equal to or greater than 30. The steps are as follows. Find the critical value, which I just showed you how to find it. Then find the error margin, E, using the formula, this formula to find the error margin. Then find the confidence interval using this formula here. X bar minus error, less than mean, less than S bar plus error. So with that, remember that the best point estimate of the population mean is the sample mean. So let's try it. The first question we'll be working on says, a sample of reading scores of 35 fifth graders has a mean of 82. The standard deviation of the population is 15. Find the best point estimate of the mean. Find the 95% confidence interval of the mean reading scores of all fifth graders. Find 99% confidence interval of the mean reading scores of all fifth graders. Solution. Part A, I'll call it solutions. Okay. So I have the several part. Part A. Well, it says, part A says, find the best point estimate of the mean. Remember, I said here that the best point estimate of the population mean is the sample mean. Now, they told us that a sample of reading scores of 35 fifth graders has a mean of 82. So that means that the best point estimate here is the sample mean. So that means that X bar is the 82 is the sample mean. So that means the answer becomes the sample mean. The sample mean is the best point estimate, which is 82. So that answered part A. Part B is where we do the actual work. Part B says, find the 95% confidence interval of the mean reading scores of all fifth graders. To do that, you list out the values. You say that a sample of 35 fifth graders. So our N equals 35. Okay. And then, excuse me, I want to get something. Check something here. Okay, this is it. And the total, the standard deviation is what? If you look at it, it said the standard deviation is 15. So we have
15.
that. Yeah, is 15. Okay. Now next is that it says sample mean is X bar is 82. Now we can't get the character for X bar, so we're gonna get it from another workbook. So let me take you to that workbook. So I get X bar. The X bar is okay. X bar is can get it from here. X bar. Okay. Hope I used the right one. Yeah, this is the right one here. I'm gonna put the right again. Insert. Make sure I have the correct character. Yeah, this is it right here. X bar is 82. Let me make it big enough. Okay. Then I copy it and then take you back to our main workbook, which is here. S bar is 82. Okay. Now, having gotten that, and we have the standard deviation. So now we can estimate our error. Remember, the formula for error is this one here. So our error is using this formula. Well, before the error, we need to get our z alpha over 2, which is the critical value. Critical value z alpha over 2 will be equal to we have already calculated this somewhere. So I'm gonna just use it from there. For the 90, it said find 95% confidence interval. We found it to be for 95%, the critical value is right here, 1.96. So we can put it in 1.96. If you don't have it, you can calculate it by yourself. I showed you already how to do it. Now let's get our error. The formula for error is here. Error equals z alpha over 2. Let me paste it here so we can use it. Z alpha over 2 times standard deviation over root n, which is z alpha over 2 is 1.96. Okay, times, let's make it big. Okay. Times standard deviation, which is 15. Okay. I think this will not give us the correct way of writing. Let me put it where we can put the right character. Let me write this down. N is 35. Delta is 15. And then what else? Z alpha over 2 is 1.96. Let me take you to where it will help us to put the formula correctly. Okay. So I'm gonna take you there. So it will look more understandable and clear. I have it here, which means we have z alpha over 2 is we have 1.96, okay, times standard deviation of wrote it down as 15 over the square root of n. N is 35. Okay, 35. And that give us, we put this in a calculator, 1.96. Okay, I'll take you to the calculator. We have, okay, 1.96 times standard deviation of 15 divided by square root of n. N is 35. And close it. That gives us 4.97. 4.97. So we got 4.97. So I'm going to put it on that workbook and copy the whole thing to our workbook, workbook, okay, which is this one. So we have our error as E equals to 4.97. Once we got this, we're almost done with the confidence interval. So now with this, we can say that the 99% confidence interval is X bar minus error. That means you subtract the error from the left side, you add the error on the right side, and that will give us the confidence interval. So we have S bar minus error. Our S bar is 82. 82 minus error. Our error is 4.97. Less than the mean. So we're gonna put less than the mean. Have a symbol less than the mean and less than okay. Our mean is, we have our mean, population mean, we don't know. That's the mean we are trying to estimate. We don't know what it is. So I'm going to copy the character from here. Okay. Less than the mean. Okay. Yeah, are we less than the mean? Okay, right here. Less than 82 minus 4.97. So that gives us the confidence limit. 82 minus 4.97. Okay, from the calculator, we have 82 minus 4.97 is 77.03. 77.03. Okay. It's less than the mean. Okay. And then less than, now on this side, we add on this side, not minus, add. So on the left side, they subtract, on the right side, we add the error. So we go back to the calculator to get the result for adding the error. So we had make changes to plus. That was 86.97. 86.97. 86.97. So the this, remember the question is about to find the 95% confidence interval of the mean reading scores of fifth graders. So to find 95% confidence interval, so we can conclude as follows. We are 95% confident that the mean reading scores of all fifth graders lies between 77.03 to 86.97. So that's our conclusion. We can say with 95% confidence, okay, that the mean reading scores of all fifth graders lies between 77.03 to 86.97. See, that's how we write the conclusion for this kind of question. So we have estimated the mean reading scores of all fifth graders with 95% confidence. So even if we are going to be wrong here, we have only 5% chance of being incorrect. So you see, you list the values, you find their critical value, you find their error margin, then you plug it in. Actually, I wrote 95. I wrote 99. It's 95%. So then you once you plug in to get the error margin, you plug it into this formula to get the confidence interval, and then you make your conclusion. Okay. When you're making a conclusion, make sure you include the parameter, which is the mean. The mean, we're trying to estimate the mean reading scores. Any question?
Yes, for the critical value, did you just grab it from the table or you had just followed those steps?
Yeah, you grab it from the table if you have it. But if you don't, see, the table gives you all the popular ones, like these ones, right? But if the question gave you 93% confidence, you can't find that in the table. So you have to calculate it by yourself using this method here. But for most questions, you'll be given this 90 or 95. So in that case, you can just grab it from the table. Okay. But if you're not given the one that is available on the table, you use this formula here and follow these steps to get it by yourself, and then use it to do your calculations. Okay?
Yes, thank you.
You're welcome. Now, this thing will time us out very soon, less than 1 minute. If it time us out, wait for 10 minutes, log back in using the same link. Okay? Hello, class?
Okay, you said it's about the timeout.
Yeah.
Class?
Yeah, time out, wait for 10 minutes, then log back in.
Okay.
And
Okay.
use the same link to log back in. Okay?
All right.
All right. So while we're waiting for it to time us out, any question?